Welcome to laboratory experiments of engineer chemistry course BCHY 101P. Today we will exercise preparation of tin oxide by salt gel methods and its characterization. Before starting the experiment, if you look multimedia, social media, newspaper, other things, you will find this is the era of nano, bio, techno and info. That means nano is a pillar of our modern civilization. People are crazy about nanoscience and nanotechnology, but nano is not new. This is not our new invention. This was there thousands and thousands years ago. People at that time they did not know that is the nano. If you look at these artworks, you can find beautiful color combination. It was possible due to uses of nanomaterials. One interesting thing is that those people knew how to prepare very small particles from bulk one, but due to instrumental problem, due to characterization problem, at that time they did not know this is in the nanoscale. Although Dr. Michael Faraday informed in 1857 at the nanoscale properties of materials are size dependent. After that, in 1959 basically, Professor Richard P. Feynman told there is plenty of room at the bottom. That means if you reduce the size of the materials, we can do miracle. But he also told when you are talking about materials, how small it is, how smart it is and how scalable it is. That means when you are thinking about small size particles, how you can make uniform or reproducible things. Now we talk about nanomaterials, means if materials having at least one dimension in the scale of 10 to the minus 9 meter, that means 1 nanometer equal to 10 to the minus 9 meter. See the picture. You can get a sense of materials having nanoparticles or nanometer scale. Now we have different type of nanomaterials like carbon based materials, polymer based materials, inorganic materials. Now if you think about our atoms and molecules, they are in the scale of 10 to the minus 10 meter. That means it is 10 times smaller than the nanomaterials. Now if you look for different application of nanomaterials, you will find nano is everywhere. Then how to prepare the nanomaterials? There are basically two type of approaches for the synthesis of nanomaterials. One is top down approach, another is bottom up approach. Top down approach means we are taking bulk materials and we are disintegrating, breaking or grinding to the smaller scale. Whereas in bottom up approach, you are starting from molecules and atomic level. Then we are going for nucleation, coalescence. By this we are making cluster and making bigger particles. That way we have two different type of approaches. If you look for top down approaches, there are many top down approaches like high energy ball milling process or machining, means we are taking big materials, grinding. Then another chemical oxidation process, electrochemical oxidation process, lithography, etching or cutting, coating and atomization. These are the process coming under top down approaches. If you look for bottom up approaches, gas condensation processes, chemical vapor condensation, atomic or molecular condensation, laser ablation, supercritical fluid synthesis, salt gel precipitation methods, spinning, self assembling or DNA origami. So, in our process we are going for salt gel methods, and when you are synthesizing the nanomaterials, we have to think about really we have achieved to the goal or not, then we have to go for characterization. So, for that characterization we are using different type of instrumental technique like SEM, TEM, EDX, XRD, XPS, FTIR, DLS, AFM and TGA. So, now after synthesizing materials we are going for different application. You look at this diagram, you can see different type of application are there. Now question is coming, why you are looking for nanomaterials? So, when you are preparing nanomaterials or you are reducing size of the materials, we can get different type of improvement in their properties like higher surface to volume ratio, higher band gap energy, higher mechanical, electrical, optical and magnetic properties, lower freezing point, higher conduction properties, higher catalytic properties. Due to this different type of improvement in properties, we are crazy about nanomaterials. Today, Professor Ramesh will discuss about salt gel methods, how to use salt gel method to prepare tin oxide nanomaterials and its characterization by XRD, X-ray crystallography.
Preparation of tin oxide by salt gel method and its characterization. First of all, we will look what are the reagent we need for this particular experiment. We need tin tetrachloride pentahydride, it is also called as tannic chloride, methanol and aqueous ammonia. And coming to the principal part, so we are going to dissolve tin tetrachloride in methanol. After that, we are going to add aqueous ammonia dropwise to the tin tetrachloride solution. The hydrolysis happens, the tin tetrachloride will convert into tin tetrahydroxide, and this tin tetrahydroxide will undergo condensation followed by polycondensation into condensed polymeric network. How this reaction is going to happen, and this hydroxy group will react and eliminates the water molecule and form this O linkase, and this reaction goes on and forms a condensed polymeric network. After that, this condensed polymeric network will be dried to get three-dimensional polymeric network. To summarize this principle, colloidal solution was made. After that, it will be converting into condensed polymeric network. Here you can see the transformation of salt to gel, and this gel again dried to convert this condensed polymeric network into three-dimensional network. And coming to the procedure part, so we are going to dissolve tin tetrachloride in methanol, and after that we are going to add aqueous ammonia dropwise. It will form the salt colloidal solution. After that, this will be filtered using a Bookman funnel fitted with Whatman filter paper, and that material was dried at 80 degrees centigrade in hot air oven for 5 hours. After that, the material is grinded and taken in silica crucible and calcinated in muffle furnace at 400 degrees centigrade for 2 hours. Once the material is in our hand, then we are going to characterize the tin oxide nanoparticles using powder XRD technique. So we have to record the diffractogram using this powder XRD instrument. The data obtained from the powder XRD diffractogram, so we are going to use to calculate the crystallized diameter. So the crystallized diameter, we can get it from the Sturge equation. The crystallized diameter is nothing but K into lambda divided by cos theta into FWHM, where K is equal to 0.9 and lambda is equal to 1.0506 Armstrongs, and theta is the peak position in diffractogram. It is also called as Bragg's angle. FWHM is full width yet of maximum, which is in radians, that we will get it from the diffractogram. Now I am going to show the reagents required for the synthesis of tin oxide nanoparticles. Tin tetrachloride, methanol and aqueous ammonia. I weighed 1 gram of tin tetrachloride in 100 ml round bottom flask, so which also contains the magnetic bead. Now I am keeping on magnetic stirrer. Now I am going to add 30 ml methanol to dissolve this tin tetrachloride. You can see that the tin tetrachloride is completely dissolving in methanol. Now you can see that tin tetrachloride is completely dissolved in methanol. Now I am going to add 1.2 ml of aqueous ammonia to this solution dropwise to make sure that it will form a homogeneous colloidal solution. Now you are able to see that a colloidal solution is forming. You can observe that the reaction is so quick. You are able to observe that the tin tetrahydroxide is forming. Okay, now this is the colloidal solution. Once this colloidal solution, you can also call it as sol. Now I am going to do filtration using this Bookman funnel, which is fitted with the Wattman filter paper. So now I am going to stop the reaction. Now I am going to transfer this colloidal solution. I am going to switch on the vacuum. So for doing the filtration, now I am going to filter it through Bookman funnel. I am going to add more methanol to transfer entire material, and moreover it assures that a complete washing of the material. After complete filtration, now I am going to switch off this vacuum pump. Now you are able to see the material, a white colored sol material is there. So now I am going to transfer this material into a watch glass or petri dish. Now I am going to scratch the entire material into this petri dish. Now you can see the material. Now what I am going to do, I am going to keep this material in hot air oven at 80 degrees centigrade for 5 hours. After 5 hours, I removed this petri dish from hot air oven. So actually after removing it will be hot. So after cooling only you have to touch with your fingers. Now you can see the material here. Now I am going to transfer this material into a silica crucible. Now I am going to keep this material for the calcination in muffle furnace for 2 hours at 400 degrees centigrade. I taken the silica crucible from the muffle furnace. After it come to room temperature, Now you are able to see the material which is in powdered form, which is we are able to synthesize this tin oxide nanoparticles. Now this material we are going to subject it for the characterization using powdered XRD technique. I transferred the material from the silica crucible to this Eppendorf. Now I am going to submit for the powdered XRD. Now this powdered XRD was analyzed, and after that the crystallized size was determined using Scher's equation.